Now I share my screen. Do you see it?
Yes, sir.
Yes. Well, let's come back to the problem statement of interpolation. In general, we can say that we have n+1 points, x0, f of x0, x1, f of x1, and so on, xn, f of xn, and we're going to find the polynomial that pass through all of these points. In other words, I can say that we have a table with the values of x and y, and we seek a polynomial of lowest possible degree for which p of xi equals to yi. On the previous lesson, we consider one of such techniques that allows us to write an interpolating polynomial. This polynomial is called Lagrange interpolation polynomial. We solve two exercises. We find a polynomial of degree 1 and of degree 2 that pass through 2 or 3 points correspondingly. And today I plan to consider one more technique, one more interpolation technique. Now I should change the plan of the lesson, because usually we find the polynomial, this polynomial using pen and paper, but today we consider how to find this polynomial using computer, how to write a program that finds the coefficients of a polynomial. Well, and this new type of interpolation polynomial is called Newton interpolation polynomial. The previous interpolation polynomial that we consider on previous lesson was called Lagrange interpolation. Now we consider Newton. Well, we come back to the initial problem statement. That we have n+1 points, n+1 data points, xi, f of xi, and we seek a polynomial of lowest possible degree for which p of xi equals to f of xi for all the points from 0 to n. Now, let's express the polynomial in the following form. I told you several times that we can write one polynomial in many forms. The polynomial will be the same, but the forms, the notations of this polynomial can be different. And now let's try to use this notation. Pn equals to a0 plus a1 x minus x0 plus a2 x minus x0, x minus xn, x1, and so on, an, x minus x0, x minus x1, and so on, x minus xn minus 1. Pay attention again that the values of x0, x1, x2, and so on are known. We know these points. It's so-called nodes of interpolation. And look into this notation, we can say that there are n plus 1 unknown coefficients, a0, a1, a2, and so on, an. And the problem of interpolation, the problem of finding Newton interpolation polynomial, reduces to the problem of finding these constants, a priori unknown constants, a0, a1, and so on, an. If somebody told me these constants, I will say that, okay, I can write a Newton interpolating polynomial. And the question is how to find these constants. To determine the first of these constants, a0, note that evaluating the polynomial Pn of x at a point x0 leaves only the constant term a0. It means that a0 equals to Pn of x0 equals to f of x0. Let's come back to this notation. Again, suppose that x equals to x0. It means that this is 0, this is 0, and so all other terms starting from this one are zeros. It means that Pn of x0 equals to a0. And we find their first coefficient on a very simple way. Similarly, when P of x is evaluated at the point x1, their only non-zero terms in evaluation of P of x1 are the constant at linear term. We will have only these values that are not equals to 0. Let's come back here again. Now suppose that I use x equals to x1. What does it mean? It means that all of the terms starting from this one will be zeros, as far as x1 minus x1 equals to 0. x1 minus x1 equals to 0. All of these terms will be zeros. Only first two terms will be not 0. And these two terms are written here. a0 equals to f of x0 plus a1 x minus x1 minus x0 equals to Pn of x1, but Pn of x1 equals to f of x1. From this equation, we can find a1. a1 equals to f of x1 minus f of x0 over x1 minus x0. Well, we find their coefficient a0. We find the coefficient a1. And on a similar way, we can find A2. How to find A2? We should just evaluate this polynomial at a point x2. If we substitute x2, we have only these three terms that are not equals to 0. And all other terms will be zeros, because x equals to x2. And after that, we will have a very simple equation according to the coefficient a2. We can solve it. We can find the coefficient a2, and after that we can write a polynomial. Well, is it clear? Do you have any questions about how to find coefficients a0, a1, a2?
No question.
Okay. Well, but if you have no questions, let's try to consider for this problem from the general point of view. How to find a coefficient for the polynomial of degree n. To find these coefficients, we should find the values a1, a2, a3, and so on. To find it, we should introduce so-called divided difference table. This divided difference can be computed very simple. The zeros divided difference of the function f of x with respect to the point xi is simply the value of the function at this point. Well, to indicate the function value, I use parentheses. To indicate the divided difference value, I will use the square brackets. So the zeros divided difference is just the value of the function. And the remaining divided difference are defined inductively. The first divided difference of f of x with respect to the points xi and xi plus 1 is denoted as f of xi plus 1 and is defined as f of xi plus 1 equals to, you see, previous, we can take the previous divided difference, subtract it, and divide over xi plus 1 minus xi. This formula gives us the rule how to find the first divided difference. The second divided difference, that can be denoted as f of xi plus 1, xi plus 2, is defined as a difference of two previous divided difference of previous degree, of first divided difference, f of xi plus 1, xi plus 2, minus f of xi plus 1 over the difference of x's, xi plus 2 minus xi, and so on. The third divided difference can be defined as a difference of second divided differences over xi plus 3 minus xi, and so on. On such a way, we can introduce the divided difference of degree k, kth divided difference. This is a formula. This is a formula of divided difference of degree k. And with this notation, the polynomial, Newton interpolating polynomial, can be written as Pn of x equals to f of x0, the zero divided difference at the point x0, plus the sum of all the terms looks like the divided difference of degree, for example, 1 times x minus x0, divided difference of degree 2 plus x minus x0 times x minus x1, and so on. So it means that we can take the values of divided differences as coefficients a1, a2, a3, and so on in this formula. This equation is called a Newton's interpolatory divided difference formula. Again, I repeat again that xi, we know it. So x0, x1, x2, x3, and so on. We know all of these points. And the question is how to find the divided differences. If we find all the divided differences, we can say that we build a Newton interpolation polynomial. And these divided differences can be computed in the form of a table. Please look to this slide. All of the divided difference can be found using this table. Here the first column is just x. The second column, the divided difference, the zeros divided difference, just the value of the function. The first divided difference, how to compute it? We can take these two values, subtract it, and divide over x1 minus x0. Okay? How to find this one? We can take these two values, subtract it, and divide over x2 minus x1. And so on. And so on up to the last term. In this example, it f of x4, x5, but actually the number of first divided difference depends on the number of points. Now, using first divided difference, I can write a polynomial of first degree. Maybe I will write you using Visual Studio in a text mode. How to write this polynomial? One of x. We can take the divided difference at a point x0 plus, according to this formula, sorry, this one, f of x0 plus, we can take, we should take f of x0 x1 times x minus x0. And if we stop now, after that we can say that we find a polynomial of degree 1. This is just a number, this is a number, this is a number, and this is a variable. Variable x in the power 1. It means that the degree of polynomial is 1. Now, if we continue this process, we can find a polynomial of degree 2. What we should do? We should add one more term here. Right here, a divided difference of degree 2 times x minus x0, x minus x1. Now, again, I repeat it. Now we have write a polynomial of degree 2 because these two terms gives us x power 2. If we stop right now, we can say that we find a polynomial of degree 2. If we continue this process, we can find a polynomial of degree 3, and so on. Well, this is the main feature of Newton interpolating polynomial, that we can interrupt the process at every moment. If I interrupt this process here, if I stop here, I can say that we find a polynomial of degree 2. If it's not enough, if we should have a more precise approximation, I should just add one more term. And now we have a polynomial of degree 3. And so on. And so on. Well, to understand how it works, to understand how this formula, Newton interpolation formula works, let's solve this exercise. Let's take this table of values, but let me write this table in the following form. Here xi, let's take first 2 points, 0 and 2. And let's write a second column, fi. Fi is 1 and 3. According to this general table, so we write these two values, x0, x1, f of x0, f of x1. Now we can find a first divided difference. First divided difference. First divided difference. Please find the value of the first divided difference at the point x0. You have this presentation. I will send you this I sent you this presentation previous week. You have this initial data, you have this data. Please find the first divided difference according to this formula. First divided difference according to this formula. It's very simple, and tell me the answer.
See, can I please write this again?
Sorry? What is the answer?
Can I please see the table?
The table. But this table is in your presentations also. I will send you this. Sorry, I sent it this presentation for your previous week, and you should have it. But okay, I show you this table one more time. Well, what is the result? What is the value of the first divided difference? You can send this result in chat. You can type your result in chat. You can say it using your microphone. F of x1 minus f of x0 over x1 minus x0. Very simple operation. I'm waiting for your answers. What is the value of the first divided difference? This is their initial data 0, 2, 1, 3, 0, 2, 1, 3, and the first divided difference. What is the value of the first divided difference?
-1. -1.
What? -1. Y -1. What is the value of f of x1? 3.
Oh, it's 3.
3. F of x1 is 1. X1 is 2. X0 is 0. X1, X1 2, F1 3. 0. What is the value? What is the value of this difference? 3 minus 1 over 2 minus 0. 3 minus 1 over 2 minus 0. And the value of the difference is 1. We compute it as 3 minus 1 over 2 minus 0. Strictly according to this formula, f of x1 minus f of 0, x1 minus x0. Well, and as far as we compute this value, I can write a polynomial of the first degree. Just substitute. What is f of x0? 1 plus 1 times x minus x0. True. 1 plus x, right? And I have this result, and this result is correct, because if I compute p1 of x0, I get f0. p1 of x2, I get p1 of x1, I get f1. p1 of 2 equals to 3. We already have this result on previous lesson when we find this polynomial using Lagrange form. Lagrange form is very useful for theoretical investigation of this polynomial, but in practical, for the practical point of view, Newton polynomial is more convenient. Okay, do you understand how to write a Newton polynomial of the first degree? Do you have any questions about first degree Newton polynomial?
So I have a question on page number 20.
Page number 20?
Yes. Yeah. So 0 is x0, and then 2 is x1.
Yes.
F1 is equal to f0.
F0 and F1. So this is the numbers 0, 1, 2, 3. This is x0, x1, f0, f1. Now, as you see in this table, the point 1 is missed. It's no the point with value of x equals to 1. We have 0, 2, 3, 5. But we find an interpolating polynomial. And now we can approximate the value of a function using this interpolating polynomial. How to do it? Just substitute it here and find that p1 of 1 equals to 1 plus 1 equals 2. The function value can be approximated by the value of the polynomial. Well, very good. Let's make the next step. Let's find a polynomial of degree 2 using these 3 points. The first 2 points still be the same, 0, 2, 1, 3, but we add one more point, 3, 2. Let's write it in a table. I add one more point. The value of x is 3, the value of y is 2. Using these first points, I find a divided difference of degree, the first divided difference at the point 0. Now, I ask you to do the same using these 2 points and find the divided difference at a point 1. Please use these 2 points, 2, 3, 3, 2, and find the divided difference. Well, this corresponds to the points x1, x2, f of x1, f of x2, and the divided difference f of x1, x2. Please find it. What is the answer? This is the formula for the first divided difference. You should take the previous divided difference and divide it over difference of x's. And here are the same in the form of table.
So can I please see the slide with divided differences? Page 16. Okay,
This,
so Yes.
Difference of f over difference of x's. The formula is very simple. Difference of f over difference of x. What is the result?
Is it -1?
Right, right. It's very, very simple. Difference of f 2 minus 3 over difference of x 3 minus 2 to -1. Let's write it in table. -1. Of course, I cannot write it like this or between these lines, or maybe I can do it like this with their breaks. Yes. Or yes. Oh, it looks very good. So we take this and this point and compute this divided difference. We take this and this and compute this one. Now let's make a final step. Let's compute their next divided difference. Divided difference of degree 2. Sorry. What we should do? We should take previously computed divided differences, these two divided difference, and divide it over x2 minus x0. Please find this value. This table now is very similar for this one.
So can I please see the formula again?
Mm-hmm. The structure of these formulas are the same. We should take the previously computed values and divide the difference of these two values over the difference of x's. Here we take x2 minus x1, xy minus x2. Here x2 minus x0.
Minus 2 over 3?
Minus 2 over 3. Maybe, I don't know. What we should take? We should take 1 minus 1, the difference of this minus 1 over 3 minus 0. Yes. The answer is minus 2 over 3. Well, if we find this value, now we can write a polynomial of degree 2. How to do it? How to do it? P2 of x, polynomial of degree 2, equals 2. First, let me write the general formula. Again, I repeat that this formula differs of the previous formula just in the last term. Now let's apply this general formula for our case. 2 of x, 2. F of x 0, 1, 1. I will write it plus the first divided difference at a point 0 and 1, 1, 1 times x minus x0. x0 is 0. So the same. The initial part of this formula is the same. Plus the last divided difference, minus 2 over 3. Let me write it with minus 2 over 3 times x minus x0, x minus x1, x1 is 2. Very simple. Very simple. And after that, we can simplify this formula. The first two terms, these two terms gives us 1 plus x, right? 1 plus x. And what we have from the last part? Minus 2 over 3 times x times x minus 2. Okay, let's write it the form 1 plus if I open these brackets, what I have for x? Here I have plus x, and here I will have minus on minus gives us plus 4 over 3x, right? 4 over 3 plus 4 over 3 plus 1. We have 7 over 3, right? 7 over 3x minus 2 over 3x squared. Let me write this polynomial in short form. 1 plus 7 over 3 times x minus 2 over 3 times x squared. Let's check our answer. First, let's substitute 0. if we substitute x equals to 0, this will be 0, and we have 1. Excellent. Let's substitute 2. X equals 2. What we have for x equals 2? We have 1 plus 7 over 3 times 2 equals to 14 over 3 minus 2 over 3 times 4. 2 over 3 times 4 equals to 8. 8 over 3. Yeah?
Yes.
8 over, well, we 8 over 3, right? 8 over 3 and plus 1, right? Yes, of course, plus 1. I forget about this plus 1. And we have finally we have 1 plus 6 over 3. 6 over 3 is 2, and we have 3. The result is correct. And finally, let's check it for 3. For 3, we will have 1 plus 7 over 3 times 3. 3 is cancelled. We have 1 plus 7 minus 2 over 3 times 3 in square. 1, 3 is cancelled, and we have minus 6, and it equals 2. Excellent. This polynomial pass through these points. And if you compare this result with the polynomial that we get for this data on previous lesson, you will find that the polynomial is the same. Because we already find it. We find this polynomial, but in a Lagrange form. The polynomial is the same. The notation of the polynomial is different. If you compare these two polynomials, you will see that the polynomial is the same. Okay? Any questions? And you see that this form, the Newton interpolation polynomial, allows us to add one more term in a very simple way. Let's do it. Let's find a polynomial of the third degree. How to find a polynomial of the third degree? Let me delete these intermediate terms. How to find the polynomial of degree 3 using Newton interpolation polynomial form? Those terms still be the same. What we should do? We should add one more term. We should compute one more divided difference and x minus x2. That's all. How to compute one more divided difference? First of all, we should have one more point. Let's take it. Let's take the last point. Let's take the last point from this table, the point with the values 5 and 6. Uh, 5 and 6, right? And what we should do to compute the next divided difference? Compute this divided difference using these two values. After that, we should compute this divided difference using previously computed this and this. And finally, we have these and these values, and we can compute the last divided difference. The star here, where we should compute the values, we should compute 3 more divided differences. First divided difference, second divided difference, and third divided difference. And after that, we are able to write a polynomial of degree 3. Let's do it. What will be the value for this divided difference? You should take these two values, these 2 points. And on a similar way, compute this one. What will be the answer? The picture is the same. The table is the same. You should take one more point, find the difference of their function values, and divide it over the difference of x's.
2/4, which is 1/2.
What? Sorry.
2/4, which is 1/2.
1/2. 2/4. No. Why 2/4? Values of f are 6 and 2, right? Yes, 6. You should compute f minus f over x minus x.
Okay.
6 minus 2 over 5 minus 3. All the computations are extremely simple here and can be done just in mind, without computers, without calculators. 6/2 minus 5/3. What is the value?
2/2.
4/2. What is the value of 4/2? 2.
2.
Right. How to compute this star? You should take this minus this over this minus this. You should let's come back. Difference of x's. x3 minus x1. The length between x is increasing at every next divided difference. This minus this over this x minus this x. 2 minus minus 1. Not 2 minus 1, but 2 minus minus 1 over difference of x's. Difference of x's are 5 minus 2. What is the value?
1.
Yes, it's very simple. It's 1. Right. And the last divided difference. Difference of previously divided difference over difference of x's. This minus this. let's come back here. Please look to this table. When we compute the next divided difference, the distance between the points increasing 3 minus x3 minus x0 for this divided difference. In our example, it will be the difference between this and this. Here the computations are not very simple, not so simple. We have 1 minus 2 over 3 over 5 minus 0 over 5. Please compute it. One minus 2 over 3 over 5 minus 0.
One-third.
Right? 1 over 3. 5 is cancelled. We have 1 over 3. Well, as far as we compute this term, it's very simple to write a polynomial of degree 3. P3 of x equals 2. You see that I repeat it again, it's very important, that the next polynomial differs from the previous one only in the last term. I can simply take the previous polynomial and add the last term. 1 over 3 times this one, x minus 0 times x minus 2 times x minus 3. If you expand these brackets and simplify their polynomial, you will obtain their short notation for the polynomial of degree 3. Well, I think you understand that. I think you understand how to find the polynomial of the next degree. We will not find polynomials anymore, but just let me write. Imagine that we have one more point, for example, the point 7 and 6 again. How to find the polynomial of the next degree? You should compute this divided difference, then this divided difference, then this divided difference, so that one more new divided difference here. So you should compute just 4 numbers using corresponding formulas. And after that, you can write a polynomial of degree 4. You see that this table looks like triangle. In the basis of triangle are axes, and in the corner of triangle is their divided difference of highest degree. And this form of a polynomial more simple in computations. It's more simple to compute a polynomial using Newton form in comparison with Lagrange form of interpolating polynomial. And yes, now we have no time, but maybe next time I will show you a simple program that allows us to find this table of divided differences using a program in C++. And if we have such table, after that, it's enough to take these divided differences, this row of divided difference, and write a polynomial in the general form, in this general form. Do you have any questions about it? The last remark is that information about Newton and Lagrange interpolating polynomials are available in a lot of books. Also, this information is available in the books that I sent you on the first lesson. And also, if you just type in Google Newton interpolation polynomial, the first link will be on the page in Wikipedia, and it's a very good page that explains Newton interpolating polynomial. You see that it's more or less the same notation. Yes, sometimes it's used some slightly different notations. Here the divided difference is denoted like this, and this is a form of Newton polynomial of degree n. And if we skip this general description, well, the same table of divided differences, yeah? The first column are x's, the next column are function values, then the column of the first divided difference, then the column of second divided differences, and so on. And the example where you may see the same triangle with the values of divided differences, and the interpolating polynomial that can be written using these obtained divided differences. Well, any questions about it? Well, if you have no questions, let's finish our lesson. The next lesson, I hope it will be on usual way, in a mixed mode in the room where where I will have a board with a chalk where I can write you these formulas on a board and give more detailed explanation. And then maybe we briefly consider some features of interpolation that we skip today. But the main topic of the next lesson will be differentiation, numerical differentiation. And as far as we skip one half of the lesson today, the next week we start our lessons 9.10 in the morning, and we will have 2 lessons. I will send you the email one day before to remind you about it. Well, now I stop sharing and I stop